Hello and welcome to today's webinar titled Data Warehousing on AWS, What's New with Amazon Redshift. Our speaker today is Myles Brown, the Senior Cloud and DevOps Advisor at Tech Data ExitCertified with over 20 years of experience in the IT industry across a variety of platforms. Recognized as an AWS Authorized Instructor Champion and a Google Cloud Platform Professional Architect and Instructor, Myles has delivered award-winning authorized IT training for the biggest cloud providers. All right, before we get started, let's cover the webinar functionalities. So during the webinar, everyone's microphones will be muted. So if you have any questions, I want you to check out the Q&A box or the chat window at the bottom of your screen now. Feel free to enter questions in there at any time as they come up. There will be a dedicated Q&A session at the end of the lecture, but like I said, don't let that stop you from asking questions along the way. If you enjoy the presentation today and you're interested in learning more about training anywhere with our interactive virtual platform called IMVP, please visit our website or contact us. I'll leave our contact information in the chat window. Today's webinar is being recorded and a copy will be sent to each and every one of you by the end of the week. Also, we'll share a new promo at the end of the webinar, so stick around to learn more. All right, let's get started. Take it away, Myles.
All right, thanks, Michelle. As Michelle mentioned, we're going to talk about what's new with Amazon Redshift, but just to set the stage, I'll do a very brief history and overview of data warehousing. And where Redshift came in. And really what a lot of the features that have come in over the last year and a half had to do with was trying to decrease the administrative burden, right? And how much administration a human has to do just to keep this data warehouse up and running and able to handle, the volume of queries, the concurrency that we need. Then we'll talk about some other features that came in that weren't necessarily around administrative burden. And we'll kind of end talking about the future of Redshift and the biggest, new development that's coming, which is Aqua. We'll have some time at the end for questions. So you can either put them in the chat or in the Q&A box. You could do that throughout. If I forget to look for a little while, Michelle will sort of interrupt and let me know if there was a question somewhere. So we'll jump right in with the history and overview of data warehousing. And I was there to witness most of this, sadly. I might not look that old, but I am. In the 90s is really when data warehousing took off. I mean, there were elements of it before that. But this is when organizations' data volume started to increase to the point where traditional databases, and there we're talking about relational databases like Oracle, where they would run into two very different competing workloads. The regular kind of transaction processing where you say, hey, I want to place insert a new order into the orders table, or I want to update a customer's last name, or, those kinds of things where it's usually, insert, update, or delete on one row, or even if we're doing queries, we're not querying the whole table, right? But then the other kind of workload really were those big full table scans where we're doing large analytic queries. A lot of times those queries, what you're trying to do is find out what customer placed the most orders within a given time, or what was the total sales for last year. So it's sum, max, min, count, average, standard deviation, those kind of group functions or aggregate functions. And a lot of times you might have a table with 40 columns in a relational database, but you're really just trying to sum one column or count the number of something in another column. And so those are very different kinds of workloads, and trying to do them both on the same machine caused some real problems. So what we started to do in the 90s was to separate it out and just say, well, let's use two different databases. One for our regular transactional stuff, and then another one that would periodically load data into. So we would extract data from our transactional database, maybe transform it, a lot of times aggregate it, and then load it into a second relational database that we called the data warehouse. And so, physically it might be just another Oracle database, but we would tune it differently. The data modeling looked a little different because we were trying to optimize it for different things. Instead of single row queries and single row insert, update, and delete and small queries, we were really trying to optimize it for large bulk loads every night of thousands and maybe millions of rows, and then really big full table scans. Right? And so I was in a place where we just had an Oracle database as our transactional database, and then another Oracle database, as our data warehouse. But eventually, some people started to look at it and say, well, how can we optimize this? How can we make that bulk load of thousands, maybe millions of rows every night? That's taking a long time. And so what we started to see was this idea of a purpose-built appliance. So we're talking about a hardware and software stack together, built specifically for this kind of thing, where we had hardware accelerated indexing so that we could load the data in, and so there was all kinds of interesting things. So companies like Teradata, Oracle had a product called Exadata, IBM had Netezza. A lot of those products are still around but changed names. Those started to pop up, and one of the big things that they would do would be that they would be columnar databases. So instead of storing the one row at a time, in a contiguous space within some block on disk, we would say, well, let's take all the customer names, all the customer addresses, all the, each column, and we would say, hey, if we're inserting 1,000 rows at a time, let's take 1,000 values for this column and store those all together in one data block. And then the next, and what ends up happening is it really optimizes for those queries where I have 40 columns in a table, but I'm only interested in one. I don't have to sift through all the data on disk for all these other columns, right? So these enterprise data warehouses would hold data collected from maybe not even just one transactional database, but a bunch of transactional databases, and maybe either other data sources. And we would bring it all together. A lot of times that bringing the data together meant, we had to clean it up before we got it there. So that process where we load the database, that ETL we called it, extract, transform, and load, a lot of it was just cleaning up the data, right? And so they were just optimized for different kinds of things. Very large inserts of a bunch of rows at once, and then really big queries on a few columns. And then what we saw, once we had the data in this data warehouse, people would connect to it using BI tools like Cognos or Tableau. Right? And so this is sort of like what a data analyst, and business analyst, probably data analyst, better term for it. And they would use SQL statements or a tool that would generate SQL statements to build reports and dashboards and sometimes do ad hoc querying as well. Right? Now, the big problem with these data warehouse appliances was that they were super expensive. I was at a place where we were really hitting the limits of our MySQL databases, and we went and we got IBM Netezza. Now, we were not otherwise a big IBM shop, but, we had heard good things and we had tested it out. And so we went and bought the smallest increment of Netezza, which was something like a quarter rack or a half rack. I can't remember now, but it was, $500,000. Wow, that was Canadian. I'm based in Toronto. But, still, it's a lot of money. And that's the smallest increment we could buy. And we rolled in that appliance, plugged it in, and we started filling it every night. We would load our rows, and they were lightning fast. And our biggest queries were fast as could be. And we were very happy. But then cut to a year later, that box is getting full. We got to go buy another increment, right? And so it's very expensive. And it was really kind of, only accessible to companies with that kind of money, who had those really big analytics needs, and they were outpacing their existing relational databases. Right? Now, the big move, in the 2010s, even a little before that, AWS came out in 2006, but it was really 2010, 2011 into 2014 when a lot of companies started to look and say, hey, let's move some stuff into the cloud. And it was really easy to move things like web servers, app servers, regular traditional databases. But then when you got to something like IBM Netezza, you said, hey, how do we run that in Amazon's cloud? Amazon says, well, we're not going to go buy hardware from IBM. That's definitely not what we're doing. So they said, we need to build our own data warehouse service. And that's what Redshift is. So they announced it at reInvent, which is late in 2012, and it finally came out in 2013. And the big idea was that it would be this MPP architecture. And you could start fairly small. You could start with just one node that's both the leader and the compute, but then you could add more compute nodes to it. So instantly it had a better economic prospect than buying one of these big appliances, because you could start small, and then as your data needs grow, then you could add more capacity to it. When it came to the administration side, well, you didn't have to worry about the physical machines, right? That's part of what moving to the cloud means is, hey, I'm trusting Amazon to take care of the data center and the physical boxes in it, right? But I still had a lot of the same basic kind of DBA tasks, right? And so the role of DBA, you might be able to handle more, clusters in the cloud than you could on-prem, because there was less of this hardware aspect to it. And there was a little bit more that was being done for you, but there was still quite a bit of burden on you. Now, and when we get into Redshift, it's worth talking a little bit about what the architecture looks like, or at least what it looked like until recently. The big idea is that you have this concept of a leader node. That's where you connect your SQL clients to it, whether it's the BI tools or whatever is running queries, or it's your ETL tool that's loading the data in. There's different things. You get either a JDBC or an ODBC driver, you connect, and you write SQL statements, right? And the leader node looks a lot like a regular relational database. It takes that SQL query, it says, hey, do you have the permissions to run this? If so, let's build an execution plan and figure out how would I run the query. But it stops short of running the query because the data doesn't live on the leader node. The data is distributed across X number of compute nodes. And so the data is really distributed around. Now, how we distribute it, it depends on your data model. Right? We have something called distribution keys and sort keys that determine, when you create a table, how will the data get spread around. And so the leader node is, where the query execution starts, and it sort of coordinates it, but the query actually runs on the compute nodes. So the leader node has to know where the data is. So the metadata is stored on the leader node, right? But it's the compute nodes that actually hold local columnar storage, right? So that's where your data actually resides. Now, it is fault tolerant. So if one of these compute nodes dies, that's okay. They've already got copies of that data somewhere else, right? And so they'll just make sure that they query it wherever it lives, and then they'll relaunch a new compute node, because it is sort of a managed service. If one of those dies, the show will go on, and in the background, they'll launch a replacement for it. Right?
Hey, Myles, can you tell us what the storage capacity of a compute node is?
Oh, yeah. So the compute nodes, you can have between 1 and 128. 128 is the biggest number of compute nodes. Now, how much can they actually store? Depends on the node type. So there's a couple different node types. There's dense storage and dense compute. But a little later, we'll see that there's a newer type. So until very recently, about the largest size of data you could store is about 2 petabytes of data, which is a lot, right? But recently, they've added a new RA3 compute node type. And with those 128 nodes, we can get up to 8 petabytes of data. So they've really expanded it out. We'll talk a little bit more about that right near the end of the talk. Now, the compute nodes hold the data. Now, you got to load it from somewhere. Now, you're really not very optimized if you're doing a bunch of single row inserts. Although it's legal, we typically load the data with something called a copy command. Usually you have a bunch of flat files sitting in S3, which is, Amazon's object storage layer. So you could have, any number of files sitting there in a bucket, and you say, hey, load the contents of this bucket. Now, assuming it's in the right format, load this data in. And it will take cues from the leader node to say, how do I distribute it? But the data gets loaded basically directly into these compute nodes. And also, when we run a query, parts of that query are going to be sent to, most of the compute nodes. And the compute nodes themselves have something called a number of slices. So it's a logical unit of parallelism within that compute node. It might have 2 or 16 slices, and so parts of that query will be done in parallel, even on one compute node, and then you multiply that by the multiplicity of how many compute nodes you have. Now, you get to decide how many compute nodes and what kind when you launch the cluster, and you can resize it later. And we'll talk about some of the resizing options. So that's the basic architecture. So as a DBA, I've got a lot of duties, right? Not only do I have to decide how many and what type of compute nodes and then go launch the thing, but every night as we load data in, all of a sudden you start to get things like, well, if I'm deleting data, the way Redshift deletes, it doesn't really delete the data right away. It just marks it as, hey, this is deleted. And then at some point, you got to come along and do what we call a vacuum operation that says, hey, let's go and actually reclaim that deleted space and then sort of defrag things to make room. And you also have to collect statistics. You know, the optimizer, you know, when the execution plan's built on the leader node, it has to kind of know when I'm trying to join this table to that table. It needs to know how many rows are in each table. And so it keeps track of this with statistics, but you have to remind it to go and collect those statistics. And so there's a lot of like day-to-day kind of administration that somebody has to do. So DBAs can automate it, but they do have, it's on their plate. And so a lot of the new features that we've seen over the last year and a half have had to do with, let's decrease that administrative burden. So the idea of doing that vacuum delete back in December 2018 is a long time ago now, that they basically said, we're going to do this for you. You know, we used to do it maybe once a week, or you looked at some numbers, and if it was not often enough, you might do it twice a week. And so you were always kind of like, oh, I got to check up on that once in a while, that automated script that I built. Now it just automatically runs based on query load. So they're going to say, hey, there's not much going on right now. Maybe it's a good time to do a vacuum delete, right? And it looks and it says, hey, if the table's got not many rows deleted, then it's fine. I can wait. I can skip that one. And so that's a little bit of the automated administration. Then they added the same thing in a little bit later for analyze. And so analyze is that idea that goes and gathers statistics, how many rows are in the table, how unique are things, you know. And every time I used to have to do this, every time I loaded the data nightly, I would think about, do I analyze the whole table or maybe just the primary key column, and then once a week analyze the whole table of all the tables? And so now they've just taken that again off your plate. When things are light in the database, it says, hey, do I have any tables with really old statistics? Then I'll go in and run the analyze automatically. Continuing on, one of the other things I mentioned, when you create a table, you have to tell them, how should the data get distributed across these nodes, across all these compute nodes? And so if it's a really small table, it might make sense to say, well, let's just copy this small table to every compute node. Then if we ever join it to something else, we don't have to move data across a network. It's, you know, it's a small enough table. It's not going to take up a lot of space. Let's copy it everywhere. But if the table gets really large, well, then you're probably going to say, no, let's take, you know, the first row and put it here, the second row, put it here, third row, put it here. And then there's another one called, you know, key distribution style. And I'm not going to get too much into the physics of that. You know, you could take a class on Redshift if you want to learn about, you know, data modeling for Redshift. But they used to just use even as the default. Now, if you don't tell it when you create a table, it defaults to auto distribution style. And basically what it does is it says when the table is new, it'll be all. So if it's a small table, it gets copied everywhere. But then as the table grows larger, they'll switch it to even. So it's just a better default.
Hey, Myles, we have a question about vacuum. What's the difference between a regular vacuum and a vacuum delete?
Okay. So that's a good question. So the vacuum, if you just run vacuum, it does a bunch of things. It does a delete and a sort, right? And so you could do two separate operations, a vacuum sort. And so when we set up a table, we tell it what's the key that it gets sorted on. And what happens is, you know, when you run a vacuum sort, it says, oh, any new rows that were added since last time we did a sort, we'll have to go and put those in the right place because the data actually gets stored by the key, right? And so if you just do a regular vacuum, it does a sort and a delete. But you could separate those and do them as separate operations, vacuum delete only or vacuum sort only. Right? So that's the idea. And so once they said, well, we're going to take care of the vacuum delete automatically, you were still stuck doing the vacuum sort whenever it made sense. And so as of just last November, they automated that. And in fact, they now have, it's a slightly different alternative to vacuum sort. It's called automatic table sort. And what it does, it doesn't compromise performance or access to the Redshift tables. So it used to be, if you did a vacuum sort in the middle of the day when we were busy, you know, your tables got really slow, right? Like some things you couldn't make changes to the table while it was happening. And even if you were running queries that got really slow. And so now the way they're doing it, it's not a big deal. One last thing, something you wouldn't be able to do until just this past November was change what the table sort key was. We used to have to go and basically create a new table with the new sort key and then copy all the data over. And it took forever, right? And all the other stuff you had on your table, you had to go and rebuild that on the new table. Now you can just change the sort key and they'll go and move all the data around in the background for you. Okay? So that's a couple of things as far as the automated administration. But probably one of the biggest changes, I'd say, came in about a year and year and 3 months ago, was this idea of elastic resize. So if you really wanted to resize a cluster, so say you said, okay, let's make a cluster, I'm going to have 10 compute nodes. And then all of a sudden, data loads start growing and growing the data, and you realize, my data is getting up to 70% full. Usually I would set an alarm for that. They would send me an email that says, hey, after the last insert of data, I'm now over 70% full. Then I would go and resize. And there were sort of two options. If you did the classic resize, you could basically say, okay, I'm not actually adding nodes. What I'm really doing under the covers is building a new cluster. If I want to go from 10 to 14 nodes, they would launch a new cluster in the background, and then it would take, 10, 15 minutes to come up, but I wouldn't notice. I could still use my regular cluster. But as soon as I started the resize, it would change it to read-only mode. So we couldn't change the data. We could still run queries. And then once the new cluster came up that was the new size, it would start copying the data over. And once it was done and the new cluster was up with all the right data, then it would do a little bit of DNS magic, and that JDBC or ODBC driver that you were using to connect to the database would automatically point to the new one. And then they'd get rid of the old one. But you were only ever paying for one cluster at a time. But there was significant disruption, right? So any current queries running or connections, they would get kicked off. And then when you connected back again, you would be in read-only mode until the whole new cluster got built and loaded with data. And then you get kicked off again. And when you reconnect, you're connecting to the new one. And so some people didn't like all that disruption. Mm-hmm. And so they would do a separate kind of restore and resize, where you would take snapshots that you can take while the database is running, and you would say, let's launch a new cluster, which is the new size, right? And then restore from that snapshot that we took. But we would have to tell the clients at some point, okay, disconnect from this database. Here's the new JDBC or ODBC driver. Connect to the new one. So neither of them was perfect, right? And both of them, depending on how big the cluster was and how complex your data was, it could take several hours. Now, if you had the classic kind of, we load the data every night, and then all we do is queries all day, then you're like, well, after I load the data, that's when I would probably realize that it's time to resize. And then you got the whole day to resize, and we're in read-only mode all day. But some people are doing a little bit more often. It's not every night at 10 p.m. or whatever that we're loading data. It's every 4 hours or every 2 hours or something. And so the resize options here were really not cutting it. And so in November 2018, they added this idea of elastic resize. And so you could quickly add or remove nodes from a cluster, and it would only take minutes. Right? And they did a really good job with it. It would literally add nodes to the running cluster, but the nodes had to be the exact same type. So with the classic resize, you could change the number or type of nodes and the size of nodes. I could go from an XL to a 16XL or whatever I wanted. So the elastic resize was really helpful. Right? And the thing that they added about a year ago to really help when we were in trouble, the idea of resizing the cluster, that's kind of like a permanent change, right? You're saying, okay, 10 nodes isn't cutting it for most of my workloads. I got to move up to 14. But when you really look at how busy clusters are, Amazon started to look at they don't have to guess. They can look at all their customers' utilization and realize that, a lot of people, it's like they got dashboards that everybody comes in at 9 a.m. and looks at the dashboard. And so there's a flurry of activities all at once. And so they said, a lot of people have maybe 1 hour a day where things get really busy. And so, if you wanted to deal with that traditionally, you would have to grow your cluster to sort of provision for the peaks. And then most of the time, you've got way too much cluster that you're paying for. You're paying, by the hour for however many nodes, right? Or you could just say, well, you know what? When it's busy, some people have to wait. Now, people don't like waiting. And so obviously that's not a good solution. So in about a year ago, they introduced this concept of concurrency scaling. And the idea was that when things started to get busy and they could figure out wait times and those workload management queues, if the queues were starting to get busy, then they would literally launch another cluster in the background. But it didn't take like 10, 15 minutes to launch because they already had nodes up and running. They were just sort of, grabbing temporarily these nodes that were already running, in Amazon's background. And they would load the data in from Redshift. Doesn't actually make, from the S3, it doesn't actually make a copy of it. It would load the data into that secondary cluster. And they could do it in seconds in an as-needed basis. And so you would configure it for certain users or certain queries, certain queues, really, and only read-only queries. And they couldn't reference something like a temporary table or a table with something called interleave sort keys. So regular kind of queries, we could say, you know what, we're getting too busy for these queries. Let's offload them to this secondary place. Okay? And sometimes you wouldn't even have to pay, because their thinking was, we'll give you an hour of concurrency scaling credits every 24 hours that Redshift is running. So once a day, you would have enough credits to run 1 hour of concurrency scaling. And when they looked at, how people's workloads really were, because they don't have to ask people, they've got all your metrics of how you're using your Redshift. They said, you know what, like 95% of people aren't going to have to pay anything beyond that. Now that 5% of people that have like a few different peak times and a lot of peak times, you would basically pay per second billing for the compute nodes, for how long they were up for that extra scaling. Okay. Now I've mentioned workload management a few times. And so it's probably worth talking a little bit more about that, because that's kind of a big part of the DBA's job, or at least it has been.
Hey, Myles, just before you get into that, can you let us know if these new features are available on existing clusters or if you need to create a new cluster?
Yeah, so the ones that came out a long time ago, mostly what they've done is, your Redshift cluster is getting updated in the background. So you don't really have to do anything to get most of these features. Right? There are some features that you have to turn on explicitly, but it's really just change a parameter and turn that on. But most of the ones we've mentioned, those are going to be on automatically. Now you can go and look at the individual features and see which ones are automatic or which ones you have to turn on. But you shouldn't have to like launch a new cluster to get any of these things. All right, so workload management, when Redshift first came out, administrators had to do a lot of work, assuming that they were going to have, one central data warehouse and then all kinds of workloads running on it, right? Like I said, you've got queries for dashboards that run every morning at 9 a.m. or whatever, and then you've got reports that run at certain times throughout the day, and then you've got a bunch of ad hoc queries, right? And part of the problem is you don't want one, rebel running really big ad hoc queries that aren't that important, and you don't want that messing up, your CEO's dashboard. You know what I mean? So you got to kind of set priorities. And so what out of the box, what you had was a single queue that had a concurrency of 5. That meant as people started sending queries to the database, we could run 5 at a time, and they each got roughly 20% of the available memory, right? And then there was one special queue just for super users. So as an administrator, I could log in as a super user and run queries. Even when things were slow, my query would get through. Okay? But as an administrator, I would start looking and saying, well, you know what? Let's make a special queue that's high priority that can take more of the percentage of memory, because these are really important queries. We've got certain SLAs on them. And so all of a sudden, how many queues to make, how much memory to utilize, what's the concurrency allowed on them. It's a real mess, and it's a lot of work that you have to figure out how to do, right? And so that's the way things have been. Now, they've added all kinds of improvements to this. One of the things they did back, it's a while ago now, in April 2017, they added the concept of query monitoring rules, where I could go and set some metric-based performance boundaries on a particular queue and say, hey, when my query's been in the queue, not even in the queue, but actually running, if it's taking longer than 60 seconds, let's abort this. So you could tell it what are the metrics-based performance boundary and what action to take when the query goes beyond that. And so you started to be able to, but actually that added to the complexity of the administration because now you have more things to worry about. And one of the things that Amazon really recognized was, when you have all these competing workloads coming in, what you don't want is one really big query to hold up 1,000 little queries, because that's 1,000 people you're angering instead of that one, right? And so they came up with something called SQA, Short Query Acceleration. They first introduced it in November 2017. Then they made it the default in August 2018. So it's still a while ago. And basically, it uses sort of machine learning to look at the query and figure out, I think this is a short query. And if it is, we jump it to a dedicated queue so they can get started much faster, and we can get those little ones out of the way really quickly. And then the longer ones can run when we're less busy with thousands of little ones, right? And so that's something they came out with. Now, much more recently, back in September, they came out with something called automatic WLM, right? The idea that let's take all of this off your plate, right? We'll create queues for you with various priorities under the covers, and then we'll use machine learning to dynamically manage the memory utilization and the concurrency on each of those queues. And so all you do is when you run a query, you tell it what's the query priority. Okay? Now, if you don't tell it a priority, then it uses normal, which is the default. But if it's more high priority, then you say hi, and it goes into a different queue that has more resources. Now, there is a sort of a hidden one called critical. That's only for super users can use that. And so that's really the easiest way to do things. Now, if you want to use this, if you have a running all existing cluster, it's by default, it's set to manual workload management. You would have to go and change the parameter group. If you change a parameter in the parameter group, that causes like a restart of your database, right? And so it takes a little bit of time. But nowadays, if you just launch one from scratch, it defaults to automatic WLM. Right? So they've really made the database a lot more self-administrating, right? And that's a big part of what they did. Now, there's a bunch of other shorter, smaller new features that maybe aren't so much about administration. They've been really busy, like over the last, say, about a year, from like about a year ago, a lot of little improvements, various improvements to the speed of querying and loading the cluster. I'm not going to get into all of them, but they show us, hey, 3.5 times faster, 2 times faster on this. And so a lot of little things. Last May, they added support for something called stored procedures. A lot of relational databases have the ability to put some code in the database and run it there. The language you use is called PG SQL. PG, the roots of Redshift are very much in Postgres, right? So when Redshift first came out, when they first deciding to build a data warehouse, they didn't build it from scratch. Amazon went and basically licensed the guts of a company called ParAccel. They had about the 4th or 5th place leading, after Netezza and Teradata and Exadata. I think it was about 4th place in the market. And they licensed the guts of that. And that product was really built on top of Postgres. So even now you can use Postgres drivers to connect to Redshift. And so it's got a lot of roots in Postgres. So you see PG all over the place. Now, much more recently, last November, they introduced something called materialized views. So a view usually is sort of like, you write a SQL statement that says, well, it's not a real table. It takes data from regular tables, but we make it look like a table so you can run queries on it. And it simplifies my queries because the complex query is hidden in what the view looks like. But every time you run a query on the view, it's really running the query on the table again and again. And materialized views, you build that view once and it actually loads it with data. And then if you run the same kind of query on it again and again, then you get much faster query performance. So this is good for repeated and predictable analytic workloads. So dashboards, certain BI tool kind of query stuff. So that's something that's available now, but only in preview. So when something's in preview, you have to basically sign up and give them your account number. And they say, there's no space left. We've already got enough people, they basically beta testing this for us. Another very new feature that's still in preview is something called federated query. They said, I don't want to have to leave Redshift to query a regular relational database and then load that data into Redshift or something, right? And so the idea that right there from Redshift, I can query tables. We'll talk about something called Spectrum that allows me to query, well-formatted files in S3, but also RDS for Postgres and Amazon Aurora Postgres. So those are regular relational databases, not data warehouses. And I can just, query the data from those tables as well as Redshift and join them all together. It's magic. Another thing that we run into a lot is this idea of data lakes, right? Where people have the raw data sitting in a bunch of S3 files. And a lot of times we want to grab data from Redshift and export it and put it into my data lake. But the regular export, we have an unload command. It just comes out as a flat file. But a lot of times in these data lakes, we want to use a fancy format that's columnar and it's binary files. And a very popular format for that is called Apache Parquet. I'm not going to get too much into what that is. If you've heard of it, good. And so now the idea is when you do an export, I run a SQL query in Redshift and I say, hey, I want to export the contents of that in Parquet files in S3. Another thing that really just came out, this is the newest thing, this came out like 2 weeks ago. Redshift now supports per second billing. So it was always you were paying by the hour. They advertised the price per hour, of various types of nodes. And if you ran it for only 10 minutes, you paid for an hour. If you ran it for an hour and a half, you paid for 2 hours, right? So it was always rounded up. Now it supports per second billing. Now that's really important for the concurrency scaling, right? Because it comes up, you only use it for a little while and it goes away. You only want to pay per second. I see some more questions. Maybe I should jump into these.
There's 2 questions about migration and customer experience. I think we can save those for the Q&A, but what about, can workload management be set up to give a group of users less resources when running a query?
Less resources when running a query. So when you set up those workload management queues, you can make a special queue that says, hey, any of these users, when they submit a query, it goes to this special queue. And so that queue, you can set up the concurrency on it. So how many queries can run at the same time in this one queue? And so if somebody goes and runs a query, a SQL statement, and it's a very long running query, well then, that's taking up one of those slots. And so obviously there's less resources available to that user if they submit more queries, right? Then there's fewer. So yes, in that respect. I mean, you could get down to the point where you set up a queue just for this user and say, hey, the concurrency is 1, they can only run 1 query at a time.
And what about query priority? How does it get chosen? Is it baked into the query or the admin assigns it? Can you change it on the fly while queries are running?
Yeah, so the idea of that is we can do it based on, if you're doing like the manual workload management, then I could say, hey, anything this user does goes into this queue, that, and they didn't have the priority concept there. Right, it was just based on the user, it would go into a queue that has more or less resources for it. Now with the automatic, basically the query priority is set as normal unless the user overrides it. Right, now you can change who's allowed to override it, right? But we could put it in the user's hands. But there's I can't remember can't remember if we can set using permissions who's allowed to run what priorities. But we can change, as an administrator, you can change the priority on the fly while it's running. Yeah. Yeah, you know what? I'm not really sure how we can set the priority for a given person, what query priorities they're allowed to use. I don't remember how that all works. Yeah, that's a good one. Okay, so the migration stuff, like you said, we'll hold on to that till a little later. All right, probably the biggest change in Redshift over the past few years was the introduction of this concept of Redshift Spectrum, right? This came out right after Amazon Athena, and it's basically on the same idea, which is I want to be able to query data from my data lake, right? And the data lake is just a bunch of S3 buckets full of files. Ideally, you know, we've got some structure to where the files are and who's allowed to touch them. But I just throw these raw files in there. And then normally what you would then have to do is take that data and load it into data warehouse and then query it from there. But the idea of Athena was, well, if there's some structure to those files, if they're comma delimited or tab delimited or whatever, or even, you know, fixed length, we could layer a table on top of it and run queries. Right? And what Athena is really doing under the covers is it's just using a big Hadoop cluster that I don't have to manage, right? That Amazon has in the background running something called Presto, which allows us to do SQL on S3. And instead of me running a big EMR cluster and paying by the hour for X number of nodes that I've got to keep track of, it just says, no. Instead, you'll pay per terabyte of data scanned. So you're really paying per query. So it's really a, you know, on-demand kind of idea, the way most of the cloud is. And so it allows you to query tables that are, you know, on data in S3 that wasn't loaded into Redshift. And the idea of Spectrum says, well, instead of having a separate tool, Amazon Athena, to run those queries, if you're already connected to Redshift and you're querying Redshift tables, you can even join to these external tables that point to S3, right? So you can use the power of Redshift, you know, to query data that hasn't even been loaded. I can join it with Redshift table data. And, you know, it's very popular with organizations that maintain this concept of a data lake on S3, right? But once we started to see this, people started to question, do I even need Redshift anymore, right? Because a lot of people with their Hadoop cluster started to see this idea of, well, I've got a landing space where I drop my raw data and then I clean it up and put it into well-formatted files. And if I use something like Apache Parquet format where they're columnar data and we can get good compression on them, well, that's the same kind of optimizations that we do in a data warehouse. Why do I need to then load the data into a data warehouse? Why don't I just do SQL on S3? And a lot of organizations looked at this. And one of the ones that's very vocal about what they did was Netflix. Right? Now, before Athena came out, they were doing this. They were running two types of Hadoop clusters using EMR. They had transient ones that would come up, say, every 4 hours and run a bunch of ETL jobs using Spark. So they would take the raw data in one set of S3 buckets, clean it up, put it into Parquet and all that, you know, good stuff, and then write that out to another set of files in a different S3 bucket. And that S3 bucket would be their data warehouse. And they had 20 petabytes of data there. And they were basically running a long-running query cluster that just ran Presto, which allowed them to do SQL queries on that S3 data. And what Netflix told us was, for what they were doing with analytics, it was fast enough. Is it ever going to be as fast as Redshift with that MPP architecture and SSD drives and everything? No. But is it fast enough for you? Right? And so some people said, yeah. Right? And what that really means is I only have to pay for the long-term storage, so S3. And I can bring up the compute when I need it and get rid of it when I don't. Right? That's very attractive. So it's that idea of separating the compute from the data, whereas Redshift, you know, those compute nodes were both. That's where the queries were running and processing, but it's also where they held the data in local disks. So some organizations, they really like this idea of SQL on S3, and they would use that as their primary analytic platform. But then once in a while, when they needed Redshift, the power of the speed of that, they could do it. So I didn't do this myself, but I had a colleague tell me about a place he worked where they were doing the Athena thing. That was their analytics. But once a quarter, at the end of each quarter, they had some really heavy-duty reporting needs. And the Athena queries were not fast enough, and they were having to pay a lot of money because you're paying per terabyte of data scanned, and they had really big reporting needs at the end of each quarter. And so what they would do is a week before the quarter ended, they would load up a Redshift cluster and start loading the data in from S3, and then beat it up for about a week with queries, and then shut it off. In the old days of physical data warehouse appliances, you would never do that. You went and paid $500,000 to buy this hardware. You're not going to just plug it in a quarter, right? So it's really interesting. And this idea is a lot easier now that the thing can manage itself. Okay? Now, the newest thing, we're finally at the newest stuff. The newest thing is these new kinds of nodes that just came out in December called RA3. And it's built on the AWS Nitro system, which is basically the new kind of hypervisor that they use. And the idea is that these compute nodes will hold the data in that local SSDs, but that local SSD is really a local cache, and the real storage would be this Amazon Redshift managed storage layer. Okay? So the data is stored and scaled separately in this managed storage layer. And this thing can scale up to 8 petabytes. And the compute nodes themselves could hold up to 64 terabytes per node. Multiply that by 128 nodes, you get to your 8 petabytes. Right? And the real magic is the fact that these compute nodes, and especially with that high bandwidth networking, they can move the data back and forth between the local cache and long-term storage, and you don't have to think about it. So this data is automatically moved between the local SSD cache and the managed storage based on some machine learning algorithms. So they're looking at what data blocks are hot, being used all the time, and which ones are, blocking other things, and your workload patterns. The nice thing, though, you pay the same low price regardless of where it lives. And the low price, if you look in most regions in North America, is 2.4 cents per gig per month, right? So it's a little bit more than S3. S3 is 2.3 cents per gig. This is 2.4 cents. So you're paying that whether they're, the storage is here or there. They move it back and forth, and it's magic, and you just know that it's, running fast. And the more storage I need, great, but that doesn't mean I have to load extra compute nodes. So if I have just 3 compute nodes, then I get 3 times 64 terabytes of local storage. But if I just keep adding more and more data, the managed storage can grow. Right? I don't have to add more compute nodes to get more storage. The managed storage can grow. We can only have so much local cache. So that's the idea of these new RA3, and it's really done this sort of separation of compute and data again that people are so interested in. And now, when we look at the future of Redshift, we see that Amazon's really doubling down on this idea. And so this concept of data warehouses and data lakes, they seem to be getting closer and closer together. And they all embrace this idea of separating storage from compute, right? Because what we find is that our storage needs, everybody's data is growing all the time. And those needs outpace the processing needs. And one of the biggest things that Amazon identified is this problem that if you look at the speed of SSDs, their bandwidth has increased by 12 times since 2012. But if you look at the speed of streaming CPU bandwidth, it's only doubled because there's bottlenecks at the internal bus connecting memory and CPU. And so really the solution here is let's do less at the compute cluster and more down in the storage layer. And so the new thing and the future of Redshift is what they're calling Aqua, Advanced Query Accelerator. And it builds on that idea of RA3 nodes, and it's only 4 RA3 nodes for now. But in that managed storage layer, it adds a distributed custom hardware accelerated cache. Now, this concept of Aqua is currently just in preview. So if you click here, you can actually get to the preview page. And you have to fill this out, and then they'll tell you, okay, we're going to contact you when we're ready, right? But they talk a little bit here about the 12 times versus 2 times, and then they get into, and I just stole this diagram right from here. But again, as long as you're using RA3 instances, then, you can just turn this on. There's nothing else you have to do. Right? So that's the concept of Aqua. And what they're finding is they get 10 times performance due to offloading operations like encryption, compression, filtering, aggregate functions. They push all those down to the storage layer. And so the data they're moving back to the compute layer is already the data you need for your query. Right? So I think
there was a question back about Athena. Is there a limit to the number of Athena partitions?
Athena partitions? There might be a limit, but it's pretty big. I've never run into anything like that. The idea of partitioning, when you create a table, just like you have in regular relational databases, you don't want to just one big file with all your stuff in it. We break it up into multiple partitions. And then when you say, hey, find me all the sales for February, I look at a subfolder that has just the data for February, and I can skip all, January, March, April. And so it's the same thing. The S3 bucket, you can make subfolders, based on some pseudo column, and then when queries go on that pseudo column. I don't remember the limit for how many, but it's a lot. If there is a limit, and I suspect, most things there are limits, but if there is a limit, it's really high. So I've not run into it. All right, so just before we get to the questions, I want to make sure I get time for this. If you want to learn more about Redshift, we have a very specific class called Data Warehousing on AWS. It's a 3-day class, instructor-led. We teach these courses, in our training centers across North America, but also through our what we call IMVP. It largely uses Zoom as the remoting technology, but it comes with some nice features. And we usually, sort of teach classes in a hybrid where some people are in class, some people are coming in remotely. And so all our instructors are very, used to that. And so the data warehousing class, it covers Redshift both from an administrative point of view, the little bits that you still have to do, at least to understand how it works, but also from like a data modeling kind of point of view, more of the developer side of things. We have a brand new class called Planning and Designing Databases. It has a chapter on Redshift, but it's really about talking about RDS and Aurora and all of the NoSQL options, DynamoDB, Neptune, DocumentDB, all these different options, and really when to use which. And so that's also a 3-day class. It's a brand new one. There's a lot of related big data technologies outside of Redshift. So I mentioned a few along the way. I talked about EMR, right? That's Amazon's managed Hadoop cluster, right? And Athena. And there's also other ones like Kinesis and AWS Glue. And so those are the things that are covered in the big data on AWS class. Again, a 3-day class. And then outside of the classes, I find the best place to learn and keep up to date with what's going on in Redshift, the AWS Big Data blog. Not the full AWS blog where you get 40 entries a day, just the ones that are marked big data. So anything Redshift will be in there, but also some of those other services I mentioned will be in there. And so there's only about 1 or 2 entries a week. So it's really easy to be a fan of that blog. If you do take one of our classes, we now have this refer a friend or colleague kind of program where you'll get an Amazon gift card. And then the student, if they come and take a course, then you'll get a gift card and that student receives a 15% off the course. And so that's, we got a link for that. I think probably, Michelle, you can put that in the chat at some point?
Yeah, so all of these classes are linked in the chat. Same with the Big Data blog and our promo code. Check out the chat window for all those links.
Okay, perfect. All right. Well, thank you. So for questions, let's go back to the open questions. I'm going to run through the ones I see here. How easy is it to migrate IBM Netezza or Teradata on-prem to Redshift? What's the typical time frame to do migration? Well, I mean, when it comes to migrating databases in general, right, sometimes it's super easy and sometimes it's really hard, right? Super easy is when you have a hard cutoff where you say, okay, everybody stop working with this. We're going to export the data and then load it into the new one, right? But almost nobody has that luxury, right? So it's hard, right? Because you have to say, well, we'll do a one-time cutover, but then what about the data that we've missed in between? There's some deltas in there. How do we get those over? The other concern is, there's different data types. There might be things like code. If you have stored procedures or something, you have to look at, hey, how easy are those going to be? Can we even do that kind of a stored procedure? And so there is a tool to really help with all this called Database Migration Service, or DMS. So if you look in the Amazon Web Services console, you'll see Database Migration Service. And then in there's another tool called the Schema Conversion Tool. That's a good place to start, where you say, hey, look at my existing schema, tell them what the target is, point them to it, and then say, what's my target, what's my source, and what's my target database? So if I'm coming from Netezza and going to Redshift, it'll say, well, here were the tables in your old Netezza, and here's the create table commands for your new ones. So we can do the schema part. But then you're going to use Database Migration Service to tell it, hey, start loading the data. Now, the problem is these things are huge, so it's going to take a long time. So the typical time frame to do migration, if you can have like a weekend where you say, okay, we're not going to do anything. We're just going to load the data over, and it's going to take us, 10 hours or whatever it is to do the actual loading of the data. And if we have that time where we say, hey, cut off, great. If not, then you'll have to leave the existing one. And Database Migration Service can help a little bit with, hey, everything that gets written there, we have to make sure those changes are also made in the new one. Okay. So learn a little bit more about that Database Migration Service. I would go to the YouTube channel for AWS and just look up DMS and watch a little bit about it. Now, when it first came out, it didn't deal with Redshift. It was really more of like, I've got an Oracle transaction database and I want to move it into RDS, but then they added in the component for Redshift coming from Netezza or Teradata. So it does support those. Curious to know any feedback from customers who have migrated from Teradata, experiences, pain points, savings. Yeah, so I think I don't know about specifically from Teradata, but one of the things that's hard to do is to benchmark stuff because, well, we can't publish benchmarks for these because if you look at your service agreement with Teradata or IBM or Oracle, they all say like you're not allowed to publish results of your benchmarking, right? So it's hard. When you look at the AWS benchmarks, they just mention against popular, they don't say the names of who it's up against. What we find, though, is before Aqua came along, everything was pretty much on par with what you would get out of an enterprise data warehouse appliance. It's just a lot less administration, right? But if you've got a lot of really specific things hooked in and using, some sort of extensions to SQL language that are specific, those are where you're going to really run into the pain points. If you've got code, stored procedures, that's going to be a problem, right? So these are some of the big pain points, I would say. Getting used to the sort of idea that Redshift is a managed service, and it's, if you can start to think about it as, hey, let's only run it when we need to, that kind of cloud idea where you don't pay for things that are sitting idle, that's a good thing. Federated queries work with EC2-based relational databases? No, yes, but only Postgres. So it might be a good way to load data volumes of data from RDS. Yeah, unfortunately, the MySQL is not an option. So right now, their first cut at it, it's in preview. Amazon is sort of famous for the way they roll out new features. They get a minimum feature set out there, and then they ask for feedback from customers, and customers say, this is great, but I need it for RDS for MySQL. And so then they'll add that in eventually, probably. But yeah, you can work with EC2-based RDS for Postgres, or even just EC2 Postgres, sorry. Is there a Redshift certification or is it part of the big data certification? It's part of the big data certification. And in April, the name of that is being turned into data analytics. So not even, I guess the big data keyword is sort of outmoded. You know, all the big companies I work with, they just call it their analytics group. And so that's, yeah. But yeah, unfortunately, that certification, you have to know a wide breadth of services. You need to know all about Kinesis and DynamoDB and EMR and Athena and Glue and Redshift, right? At a pretty deep level. So to really get prepared for that certification, you almost have to do both those 3-day classes. All right, we're past 1 o'clock. I went a little long. Sorry about that.
Just one more question. Do you know if there's a serverless Redshift on its way?
Yeah, that's, I mean, they haven't said anything, you know, they don't do much in public roadmaps, right? The fact that Aqua is out, you know, it's telling me that they're taking it pretty seriously about this idea of managing all the storage for us and not having to worry about it. So it's got to be that the compute nodes are next, but when, who knows? You know, they haven't really stated anywhere that that's coming. Now, one of the things you can do is, you know, in an individual basis, if you've got like a enterprise support, you can say, hey, put me in touch with the TAMs, you know, get your TAM to put you in touch with the SMEs on Redshift. And they might have you sign a specific NDA just for that, where you can ask about it. But you know, they don't give much in public roadmaps to tell us what's coming like that, unfortunately. All right. Okay, so I guess the recording will be sent to you at some point. If you didn't get a chance to save all those links, in the chat, there's a way to save the chat.
Yeah, if you open up the chat window, find the More button at the bottom right corner, click Save Chat, and you'll have all those links there. These questions will also be included in the recording that we're going to send to you, hopefully by the end of the week, if not early next week. Actually, just got confirmation, you're going to have that by tomorrow. We are at the end of our webinar now, and I know we went a few minutes over, so thank you so much for your time. If you have any questions that you just didn't get the chance to ask, don't hesitate to reach out to us, and hopefully we'll see you in one of our classrooms very soon.
Thanks a lot, Michelle.